guys, sorry. I really hate this 5-minute timer, but I refuse to pay for Screencastify. So I paused the video and stopped it after we solved example number 3. I set up a new piece of paper, but it was essentially this big, long example that we just did. Here is the 4th example. This is actually something that students typically don't learn until 8th grade. So you're kind of getting a preview of it now. In this case, we have a variable on both sides of the equation. So our goal with this kind of problem is we want to get the variable on one side of the equal sign, then the constants. So essentially, we want to try to take the x's and put them on one side of the equal sign and take the constants and put them on the other. Because again, the ultimate goal is to get x by itself. And even though x is on two different sides of the equation, we can kind of maneuver our equation around using the properties of equality to figure out what x is equivalent to, because it's showing us these two equivalent expressions and x is going to be the same value. So the first thing we want to do is we want to try to get x to one side of the equation. So we can use our properties of equality on x. So for example, this is positive x right here. So I can move x to this side of the equation by doing the opposite of what's positive, or the opposite of addition, which is subtracting. So if I subtract x, if I want to move it from this side to this side, I'm going to use the properties of equality. I am going to subtract x from its like term over here, 5x. These are like terms from each other. So if I do this, my new equation is 5x minus an x is just going to be 4x. You could think about x by itself as 1x. 5 minus 1 is 4. So 4x plus 12 equals, I need to make sure I keep that negative sign, negative 8. So this looks more like equations we've already solved. So the next thing we're going to do is we are going to simply follow the 3-step process. So we kind of combined our like terms by moving that x to this side of the equation. Now we're going to get rid of the constant, which is 12. We're going to do the opposite or the inverse operation of addition, which is subtraction. So if I subtract 12 from both sides of the equation, my new equation is going to be 4x equals negative 20, negative 8 minus 12. We're going farther in the negatives. That is negative 20. And then to get x by itself, I need to get rid of its bestie, its coefficient. So I'm going to do the inverse operation of what's being done here. So this is 4 times x. So the opposite of that is to divide, or the inverse operation is to divide. If I divide both sides of the equation by 4, 4 divided by 4 is 1. 1 times x is just x. Negative 20 divided by positive 4 is going to be negative 5. So x is equal to negative 5. And if I went back and if I plugged in negative 5 here, and if I plugged in negative 5 here, I would end up with the same number on both sides of the equation. I have time in this video, so I can show you real quick. If I go plug it back in, I'm going to kind of do it really small right here. I will have 5 times negative 5 plus 12. And then on this side, I'm going to have negative 5 minus 8. So negative 5 minus 8 is negative 13. And if I solve this, this is negative 25 plus 12, which is also negative 13. So we do end up getting the same thing on both sides of the equation when we plug in negative 5 for x. So essentially all we did is we combined our like terms, but we did that by moving our variable to one side of the equation. I suggest, if you are having trouble, to go back and look at this example as well as the previous examples on your multi-step and one-step pages before you work on your homework or any of your mastery checks. Thank you guys for being patient. Sorry my videos get cut off. Do not dislike my videos. I need the likes. I need that validation. You guys have an awesome day.